Hi, this is Pat Schuff with Making the Space. In previous videos, we had done some laser cutting and did some drama masks. Went through and showed how to take the image from the internet, rasterize it, take it into RDX tool, and then once we had it in RDX tool, how to make it work properly on the laser cutter. Fundamentally, the problem was the rasterization process was not clean, was not smooth. If you zoom in or make the image larger than, say, a coaster or a coffee cup, taking it to a 2x2 square, 2 foot by 2 foot, makes it pixelated, and it just doesn't look good. So in this video, we're going to look at another way of doing this. We're going to pick some Calvin and Hobbes images and see if we can create some snowmen, blow them up, and make them large enough to put in the front yard. There are lots of images to choose from. The raster images or the JPEG images that we can get are relatively small. We can blow them up. We can make them a little bit cleaner as long as we realize these are copyrighted materials. Can't really buy them or build them to sell. This is for personal use only. To create the laser cut image, we're going to use Adobe Illustrator to pull in a JPEG file, put a layer on top of it, and then trace around it using vector tools that are in Adobe Illustrator. We could use Lightbox, we could use a variety of other tools. I just happen to own a license for Adobe Illustrator, and this is the default tool at TXRX Labs. So the product's available to anybody who goes into the lab, can use it, and then save it as a DXF file, and from there we can take it to the laser cutter. One thing to note with Illustrator is the default scaling is with points, because it's typically used for typesetting or creating images that go on paper. Since we're trying to take this to a laser cutter, points really don't mean much. We need to switch over to inches, and if you go to View Ruler, it'll show you the measurements on the page so you can scale it to the right size, and then you can open up a custom page. We're just going to use an 8.5 by 11 and then vectorize everything and then scale it once we get to RDX tools. So let's start by going back to our drama mask image. We'll download it and import it into Adobe Illustrator and create a new layer that we will trace on top of. If we remember, when we zoomed in, we got very pixelated scans because RDX tool assumes a certain number of points per inch. Whereas with Adobe Illustrator, we can define how we want the points to be spread across and how we want it to scale when we blow it up to 2 feet or 4 feet. Scaling in Adobe Illustrator can be done by grabbing a corner of the image and sliding it down. One of the drawbacks is it doesn't scale it uniformly. We might scale it in the X direction or in the Y direction, but we'd like a uniform scaling. So rather than dragging a corner and pulling it down, we'd prefer to go to Transform and then scale it uniformly in all directions. Once we've got the image pulled in, we can scale it up, scale it down, scale it appropriately so that it fits within the 8.5 by 11 sheet of paper. Scaling up and scaling down is a relative term. It's relative to what the previous operation was. So if I scale 110% and then scale another 110%, that's really not 120%, it's a little bit less, and then I can scale it down again. Now once I've got it scaled, I can position it, and then I can crop it and get just the image and get rid of the text at the bottom of the screen. Once we crop the image, we can create a new layer, and the new layer will be our drawing layer. I typically go in and label the original image layer, image, and then the new layer that we create, vector or drawing or some other label, so that I know the differences. And I can turn off the image by turning off that layer and make sure that the drawing is exactly what we were looking for. Now that we have everything positioned, we'd like to zoom in and get as much detail as we can so that when we use the pen tool, we can create points along the curvature of the drawing. And with this, we can zoom in, zoom out. We don't have to see the whole drawing when we do it, but it does help to see as much as we can to create smooth transitions. You can use the slider bar at the bottom to slide over and get different parts of it, but typically I zoom in best to the ability to get as much of the image as possible on one screen. Once we select layer 2, we can start drawing by selecting the pen tool and then click points along the image. In this example, we're going to click as few lines as possible to create as smooth a spline transition that we can. As we get to hard points, we might need to add a few more points. As we get to smooth transitions, we need fewer points. In this example, we did 5 points across the top of the happy mask. We could have done probably 4. Might need to do a few more, but the idea is create as few points as possible to create the curvature. It does fill in, so it makes it a little bit more difficult. You really shouldn't start at the bottom and work up. You should start at one of the corners and work back to it so that you get good coverage. Now I can turn it on, turn it off. I can flip so that the image is always in front and the drawing is always in back when I'm looking at it, and then activate the drawing layer so that I see everything as I'm drawing it. With the JPEG image behind the vector drawing, I like to go and drag the dots until I get all of the black covered. This is kind of a finesse thing. You might need to add a point here and there to create a better curvature, and then once I've got it finished, I flip it and then have the vector drawing in the back and the JPEG image in the front, so that I make sure that I've got good coverage on the outbound, and then make sure I've got the indentions and the curvatures that work on the inside just as easily. It's important to point out that in the Illustrator, we're not using the pen tool to do this fiddly work. We're using the point tool, which is to the right of the pen tool. That allows us to take existing points and drag them to create more of a smoother spline, or add more points to create more of a curvature as opposed to a straight line. Minimal points is best. If you remember the scanned image that we did with RDX tools, it used probably about 40 points for every 2 points we've got here. And in this case, more points is not good as the image scales. Notice when we flip the order of layer 1 and layer 2, layer 1 becomes the front, and we can see where we've overshot with the vector lines, and correct it by adding more points, sliding points around, just like we did when it was the opposite direction. Once we have everything saved, we can save it as a Illustrator file as well as a DXF file, so that we can import it into the laser cutter. You can save it to the cloud, you can save it to a local disk, you've got a variety, but eventually we're going to copy this to a USB drive as a DXF file. All right, so let's start from scratch. Let's open up Adobe Illustrator and create a new page. We'll create a new blank 8.5 by 11 sheet of paper and get ready to import a JPEG image into it. The size of the paper doesn't matter. The intent is to create a vector drawing that scales, and that way we don't have to worry about the size. We can start with something small, test it on a sheet of paper, and then scale it larger to a sheet of plywood. To rescale the drawing, you can drag from the corner, but I find that that doesn't necessarily preserve the integrity of the X and Y coordinates. It's better to right-click, click on Transform, and then Scale. And you can scale it up or down the same way. It's much easier to do it that way. And that way you're ensured you're not skewing it too tall or too wide. Once you've got the image to the right size and on the sheet of paper, I typically go through and add a second layer and then go back and relabel the first layer as image or JPEG or whatever I prefer. The idea is you're going to do all the vector tracing on the second layer, and the first layer will be there for reference only. Once you've finished doing all the tracing, you can hide the JPEG layer and not see the original image, and you can see if your tracing has picked up every line that you need to. Make sure you've got the second layer selected and not the original JPEG layer, and you can do drawings on top of this. What we'll use is the paintbrush tool. We'll select the paintbrush tool, which is the third one down on the right-hand column, and using the open bracket, close bracket, the square brackets, not the curly brackets, that increases the brush width. Unfortunately, I use a touch screen with a pen to draw all the lines, so I can trace the drawing from the original JPEG image. And once I've got that done, I've got an image that can be rasterized onto the wood by using the trace element, and that allows me to have a thick, bold line burned into the wood. At this point, we should have all of the elements traced. To verify it, we can click on the eye icon next to the JPEG layer, and that will hide the original drawing, and we can see that everything comes through. Now that we've got everything drawn, we're going to create a third layer, and this layer will be the vector drawing cutout, so that we can cut out the outline and layer the plywood to create a 3D effect. To create the cutout outline, we use a different pen. We use the pen tool, which is the second one on the left column. And what that does is allows us to draw splines around the item. And what we're going to do is cut out the snowman and the snowman's head, but leave the arms and the golf club on the existing plywood. The concept here is we're going to scan everything on the laser cutter, which will burn in the paint drawings, and then we will cut out the snowman and the head and raise a piece of it off of the plywood to create a 3D depth effect, which will enhance the look as it's in the art. Once we finish the cut outline, we can turn back on the JPEG image to make sure we've traced around everything we need. And if we're unhappy, we can drag the dots to make it a little bit closer to the profile, or add a few more to make it a little bit smoother cut. Finally, we save it as an Illustrator image, and then we export it as a DXF, because that's what we need to go to the laser cutter. RDWorks is the default tool that's provided for the laser cutters at TXRX, so that's the software that we use to control cutting on the laser cutter. The tool is kind of crude. We could import the image and then vectorize everything in here like we did with the drama masks, but it doesn't give us the smoothness of the cut. It's more of a jagged cut, and Adobe Illustrator allows us to provide a smooth transition of lines. Now, one of the problems by importing the DXF file is that it doesn't understand the scale of the laser cutter. So you have to drag and drop the corners to scale it down to the size of the laser cutter area. You can do that either by dragging your corner, because it does keep the ratio of X and Y appropriately. Or I could go up and hit the lock button and then scale appropriately by typing in how many inches I want it to be in the X direction, and it will scale appropriately in the Y direction by doing that. Either way works. I drag and drop typically because it's easier to visualize. If I'm looking at cutting a very specific width, then I will go in and say I want it 24 inches wide and make sure it's locked so that it scales the Y appropriately as well. So the final step in RDWorks is to select everything, make it a scan, because what that will do is the thickness of the line that you drew with the paint tool will be etched into the wood when you cut it. Scanning is different than cutting in that it rasterizes and goes line by line. It takes forever to do it. To do something of this size, about 20 inches tall by 15, or 20 inches wide by 15 inches tall, will take about 2 hours. So we select everything, we set it as scan, then we select the line that we use for the cut element, and you have to select both of them. Select a different color and define it as cut. Once we do that, we save the file to make sure we can recover it and bring it back in to export to the laser cutter machine laptop. One of the drawbacks of the laser cutters that are in the lab is when you do a scan, it doesn't show you what it's printing. So you can't really look and see as it goes line by line what it's etching. You have to actually look inside the machine or pause it by clicking the Start Pause button down at the bottom left to make sure it's getting the right depth, the right width, the right everything that you need. It's not recommended to look inside the laser while it's cutting. I typically use a camera, take a picture, and then bring the camera up so I can see what's going on. For the golf image, it took about 2 hours to do the scan. It was relatively simple. It just goes line by line, raster by raster, and draws everything appropriately. When you get down to the bottom, it doesn't take the whole width of the scan. It just scans the golf club head. So it looks a little funny in that you've got these long scans, and then all of a sudden it goes zip, 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 zip real fast and down towards the end. We can repeat this whole procedure for 2-3 other images, however we want to do it. Snowman holding his own head, a kid sliding through another snowman on a sled. And we can see the cut comes out pretty clean. The outline comes out clean. We added a border around everything so that the pieces can be stacked and glued together. It's relatively simple to do. It takes 3 cuts. The first cut is the scan. The second cut is the internal outline. And then the third cut is the base backing, which is just the outer outline. By doing this, we get a nice clean piece and can cut, stack, paint, and then seal them so that they can be outside in the elements. And the final step is to glue up all the pieces. Notice the snowmen on top are raised, so they have kind of a 3D effect when you look at them from the side a little bit, giving it a little bit better profile. So once everything's glued together, we then paint the white, we paint the laser cut edges black. We go back and do 2 or 3 coats to make sure everything looks good, look at it from different perspectives, and have 4 of these that we've cut out and 3 of which we've painted. The final step is to put polyurethane on it to make it weather resistant because we don't want the plywood peeling. So we polyurethane the sides, the front and the back, and then put clamps on the back so that it can be put on a post and stood up in the yard. Overall, this has been a pretty fun project, going from raw cartoons to sketching it on a computer to cutting it out on a laser to assembling and painting it on wood. There's tons more that can be done. I just did a few samples and lots more to do in the future with this and a variety of other hand sketch cartoons and comic books and a variety of other things you'd like to do.
Now back to your regularly scheduled program.
And while some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.